Come on. There we go.
So can you...
Yeah. Wow, you made it. Like this? Okay. Continue. Yeah. Well, I don't like the pink. That will do. Trigonometry 2. In some ways, the sequel is better than the original, but you'll see now. So the good news for you, I know your brains are still tired and sleepy from, because I mean this is probably the first time you were awake at 9 o'clock, 10 o'clock last week, would it be? Yeah, fantastic. So to get warmed up, the first lesson is pretty easy, which is good for you. So, last semester and this semester we all studied and familiar with sine, cos and tan, and when we look at the triangle, there's the opposite, the adjacent, the hypotenuse, and let's say there's x. There's actually 6 ratios you can form here. So you can have O over H, A over H, O over A. But you can also have H over O, H over A, and A over O. Now there's actually 3 more that you can have, but they don't make any sense. O over O, A over A, and H over H, but they're silly to look at because they're always 1. So these 3 are given names as well, just like these 3, sine, cos, tan. So this first one here is called cosec. It's written like this, or sometimes you might see it written like this. And that's the hypotenuse over the opposite. Okay, so that's the first one. The second one is sec x, which is always written as sec x. I can't think of other ways to write it. And that is H over A. And the last one, cot x, or cotan x, that's in some countries, like in Vietnam, they write it like this. Just so you know, which is the last one, A over O. And just so you know, here, this full name is actually cosecant. Its full name here is secant, and its full name here is cotangent. Okay, so if you can write those down.
The first one is cosec.
Cosec or cosecant, yeah. You got that? Now you'll notice also, because of this definition, you can actually also say cosec is, hang on, let me put that in pink. This is 1 over sine x. It's the same thing as 1 over cos x, and this is the same thing as 1 over tan x. Yeah.
So can I say that sine inverse 1x is...
No, that will get a slap. Yeah. Yeah, such things make baby Jesus cry when we say things like that. Really, really painful. Because, and you said it before I got a chance to say it, that this here is not this. It's not that. It's not. Now, we talked about this previously. I remember having a long discussion with KJ about this. So KJ can tell you more. But it's just unfortunate that we use the same symbol to mean both the inverse and 1 over. And actually here, this does not... This is a very common mistake students make. And I think it would be better if we didn't use this to mean sine inverse. If we did what the Americans do and use a different word, so if we instead use something called arcsine, then you wouldn't be confusing that with that. It's only because we have the same symbol here. In fact, this, if I wanted to write it as a power, would be like that. And annoyingly, that is different to that. Sorry to tell you this, so you need to be careful about that. So I told you this, but some of you will forget this, and in a few weeks you'll ask me, teacher, isn't this the same thing as sine inverse? Try to remember that it's not. Okay? We got those three? Yeah. So what we need to have a look at now is the graph of them. So if you can add your graph, because sometimes in the exam they ask for the graph of these. So the first one we'll do is cosecant. So this is cosecant, and I probably want to go out a little bit. There we go. Now 2 pi is about here, and 2 pi is about here. So let me just go to yeah, that'll do. So that's about 2 pi. Okay. Right, so that's the first one. That is cosecant. Now, notice how for sine, what's the biggest sine could be? 1. And you notice on this graph, it's the opposite. The smallest it can be is 1 and goes off to infinity. In fact, you cannot have values between... You can have -1 and 1, but you can't have values between -1 and 1. Yeah, and this shoots off to infinity here, and this point here, what's this point? If you're to judge on the graph?
Pi.
Pi, yeah. Yeah, it's about, that one there will be pi. There. And then this one here, 2 pi. And likewise here, that one there is minus pi. Let me put it in properly. There we go. Right, can you draw this graph, please, to add it to your notes? You can make the graph from that? Nice. Yeah. Next graph. So the next one we'll do is the secant. So that's 1 over cos. So let me just close that. Okay. Looking pretty similar, but that kind of makes sense because sine and cos are pretty similar. What's this point here where it breaks? Yeah. Let me put this in. Yeah, the other one broke. I got one class out of it and now it's broken.
How it can be possible?
Huh?
How it can be possible?
I don't know. Dennis wasn't lying when he said it's nearly broken. So, I put my operating system on it and I took it to this class. And I did one class with you guys and that killed it. It won't turn on. And it's not because of the power supply, because I checked with a voltmeter that there's power coming out of the cable. And it's not because of the battery, because even when I take the battery out and plug it in, it should turn on. It doesn't turn on. So there's something wrong inside of it with the power. So it's not worth fixing now.
So you have to throw it away.
So I'm back to the old, reliable, trustworthy laptop. Okay, you got that one? So next one now is cotan. Which now looks like this. And these points here, I think we get pi over 2, yeah. Okay, if you can add that one in. Got that? Yep. Now on to some calculations. So one thing, I don't know about this calculator, maybe not, but on most of your calculators there isn't a sec, cosec, cotan button. Is there on this? Yeah, nice. So the next doesn't really apply for you and your calculator. So suppose I ask you to do something simple like calculate, let's say, the sec of 30 degrees, cosec of, let's use pi over 4, and let's say cot, let's use 45 degrees. Well, you don't have these buttons on your calculator, but it's not really a big deal because you just have to type in 1 over cos 30 in degrees mode. This one here is 1 over sine pi over 4 in radian mode. That's actually root 2. Cos 30, this is 2 over root 3, I think. And that's a 1 over tan 45, which is 1. It's not, it's 2, is it?
Yeah. 2 root 3 or 3.
That's the same thing. Yeah. Same thing, yeah. Yeah, same thing as 2 root 3 over 3. Just multiply the top and bottom by root 3. And you get 2 root 3 over 3. So you forgot from semester 1, rationalize the denominator. Do you remember this lesson? Long time ago. You multiply by the conjugate. Conjugate. Anyways, this is okay, this is okay, this is okay, yeah? Much harder to do is the inverse. So I'll give you a minute to try and figure out how you might calculate something like this. Secant inverse of 2. And I'll give you a little hint. My hint is you need to think about the F inverse lesson. No, the inverse lesson. Inverse. Where you have to find the... We did this lesson, yeah. You have to find the inverse. That's my hint. Okay, I'll give you a minute now to try and figure this out. Because you don't have this button on your calculator, so you'll need to think about what to do.
Teacher,
Yeah.
for secant 30, can we write the decimal number?
What do you mean? Oh, the answer?
Yeah.
Depends on what they ask for in the exam. If they use the word exact, then you need to write it like this. Otherwise, you can use decimal.
Oh, your calculator can.
Yeah, how are you going to do that?
Does your calculator do it this way?
I have to raise my hand.
Can I borrow a calculator, please? It's a calculator.
When students ask for calculators, it makes me sad. I see you still don't want to buy a new one. You know, you could have both in the exam. There's no limit. You could have a pile of 10 calculators. There's no limit.
No, it's the same reason why you don't change your laptop.
Now, I tried to change. You saw me. I tried to change, but it failed. Did you figure it out? No? Yes? No. Nobody got it? This question has stumped you. No? Not happening? Not happening. Okay. I'll show you. You'll be sad. Don't be too sad. So, if I have fx equals sec x, and I want the inverse, you know how to do this. We say y equals sec x, yeah? Y equals 1 over cos x, yeah? Cos x equals 1 over y. X equals cos inverse 1 over y. So therefore, f inverse x equals cos inverse 1 over x. So therefore, sec inverse x is the same thing as cos inverse 1 over x. So that means my question of sec inverse 2 is just me asking you for cos inverse a half. What is cos inverse a half? I think that's 6
T.
D degrees is the answer. Yes. This we did. Can I just check which page that is? Sorry, thank you. That's page. Yeah, thank you. This is what you learned on page 18 of your book. Okay, did you write that down? Yeah? You get the idea? I'll give you another one to try since nobody got it. Try this one now. Give me cot inverse 2. Yep. Got that? This, I'm sure you've worked out, is the same thing as tan inverse 1 over 2. Yeah, so what did you get for that? 26.56? Yeah, that's really it. So like I said, the first lesson now won't be that hard. But don't worry, it gets harder now in the next lesson. Yes, much harder. Okay, so what would be great is if you could do, you know, a sec, a cosec, and a cotan in each. That would be good practice. Then once you've done those few, I think you can, yeah, a little bit earlier, I know, but once you do those few questions, you can take a break then, because there's nothing else in this first lesson, okay? Can I close that? What is it exactly?
Jelly bean. It's not that nice though, for me.
I also don't like jelly beans, if they are what you say they are. Jelly beans, like the little, it looks like a bean.
Yeah.
Take one out so I can see to confirm. Yeah, I don't like those. There's two sweets I don't like.
Yeah.
Jelly beans and those Malaysian fish sweets.
Yeah. Fish sweet. What is fish sweet?
Those Malaysian sweets that taste like fish.
That is durian. And it is nice.
It's, yeah, you see, it's not.
Gosh, it is the king.